Okay, and those things are very important for your future classes, in the coming classes. Okay, yeah. So we actually will use the symbols of these flip flops here. Okay, so instead of using all the circuits, we'll be using the flip flops, the symbols like this. Okay, so there are two kinds of flip flops: the positive edge triggered and the negative edge triggered. The positive edge triggered is represented like this. So this is the clock here. The negative edge triggered is represented like this. Okay, so this is a D flip flop. So JK will be having two flip flops and a clock here. Okay, and so coming to T, we'll be having a T flip flop and a clock here. So this is how we represent the block diagrams, right? So now what we'll see here is these are the characteristic equations. Okay, so these are the characteristic equations of a different flip flops here. So D flip flop, so Q of T plus 1 is equal to T plus 1 or N plus 1 is equal to this one, D. So JK flip flop, Q of T plus 1 is equal to, so J Q bar plus K bar Q. Okay, and T flip flop, it is T exclusive of Q. So we already seen this, and S of flip flop is S plus R bar Q. Yes or no?
Yes, sir.
Okay.
Yeah,
So
sir.
guys, those things in the last class. Okay. So now what we'll do here is we'll check the excitation tables. So whatever the tables we'll discuss right now is about excitation tables of the different flip flops. So I'll let you know what is the excitation table. Okay. So we'll see the differences between the truth tables and the excitation tables. Next we'll go for the conversions of the flip flops. Okay. So how to convert one flip flop to the another flip flop. So how the conversion process takes place. Okay. So we'll see all those things right now. Okay, and yeah. Okay, so first of all, what will be the truth tables? We'll talk about the truth tables right now. Okay, the truth tables are so truth table of SR flip flop. So in short, okay, so we already had this truth tables. So 1 minute.
Excuse me, sir.
Yeah.
Some are waiting to join.
Okay. Fine. Okay, so these are the truth tables here. Okay, so there's a truth table of SR flip flop. So 0 0, it's a Q of N. So 0 1. Okay, so 0 1, it's a 0. So 1 0, it's a 1, and 1 1, it is an indeterminate state here. And the equation for this this one is Q of N plus 1, that is Q of T plus 1 or N plus 1 is equal to S plus R bar Q. And a D flip flop truth table is this one. Okay, so D is equal to 0 and D is equal to 1. Okay, so Q of N plus 1 will be equal to 0 when D is equal to 0, and Q of N plus 1 or T plus 1 is equal to 1 when D is equal to 1 here. So the equation is Q of N plus 1 is equal to D here. And coming to this T flip flop, when T is equal to 0, the output is Q of N. Okay, the output is Q of N. When T is equal to 1, the output is Q bar of N. You will get the toggle state here. Okay, so coming to JK flip flop, 0 0, it's a Q of N. 0 1, it's a 0. Okay, so it is same with respect to SR flip flop, but the last state is, instead of indeterminate state, we'll get a QN bar. Okay, we'll get a QN bar there. Okay, so are you clear about this? You're clear, right?
Yes, sir.
Yes, sir.
So now what we'll see here is, so we can check here. Okay, so when the inputs are is equal to 0 0, we are getting a QN here. Okay, so we are giving the inputs and we are getting the outputs here. Okay, we are giving the inputs and we are getting the outputs in case of the truth tables. Excitation tables will be the reverse of this. Okay, excitation tables will be the reverse of this. We'll check the present states and next states. Okay, we'll check the present states and next states, and based on the present states and next states, we will decide the inputs here. Okay, we'll decide we will decide what are the inputs which are required for the change of state here. Okay, so what is the present state? I'll say that it is q of t or q of n, and the next state will be q of n plus 1, okay, or t plus 1. So I'll analyze this present state and next state. I'll analyze the present state and the next state. So afterwards, what I'll do, so I'll identify the inputs which are responsible for transition of this present state to the next state. Okay, so the main aim of these excitation tables is we'll mention the present state and next states. We'll mention the present states and the next states. Okay, and for example, if the present state is 0 and the next state is 0. Okay, and for example, if the present state is 0 and the next state is 1, and next if the present state is 1 and next state is 0, and the present state is 1 and next state is 1. Okay, so these are 4 possible states for the given things here. So what we can do here is, so we have to analyze which inputs are responsible for the state changes. Which inputs are responsible for this state changes. So a little bit of confusion will be there, but it's fine. It's very easy thing here. Okay, so you can see here. So wait a minute. Yeah. So reverse of this truth table is nothing but the excitation tables. Okay. So if I say that S and R here. So S and R is 0, 0, right? So 0 to 0 state here. Okay. So I'll call it as 0 to 0 state. I'll call this as 0 to 1 state. I'll call it as 1 to 0 state, and I'll call it as 1 to 1 state. Okay. In other ways, what I can say here is no change state, 0 to 0 state, right? Okay. So present state is 0, and next state is also 0 here. There is no change in the state. Okay. The present state is 0, next state is 1. It is a complementing state. And 1 to 0, it is a complementing state, and 1 to 1, it is a no change state. Yes or no? So understand in different way, understand in reverse way here. Okay, so excitation tables, what excitation tables will check here is, so excitation tables will give the reverse of the truth table. So where we'll be having the present states and next states. Okay, and we have to identify the inputs which are responsible for transition from present state to the next stage. Okay, so we have to identify the inputs which are responsible for the transition from the present states to the next states. So getting my point here.
Yes,
Yes,
sir.
sir.
Okay, so మనం ఇక్కడ ఇన్పుట్స్ ఇచ్చి నెక్స్ట్ స్టేట్ కనుక్కున్నాం. ఓకే, సో ఇక్కడ ఏం చేస్తామంటే present state నెక్స్ట్ స్టేట్ ఇచ్చేసి will identify the inputs which are responsible for the state changes. So q of n to q of n plus 1. Okay, so we'll identify the inputs which are responsible for change of q of n to q of n plus 1. So that is what we are going to do right now. Okay, so these are the truth tables here. Okay, what we'll do here is, so we'll identify the excitation tables right now. Okay, SR flip-flop excitation table. So this is the truth table. Okay, truth table, and what we need is excitation table. So excitation tables, what we mention here is, I'll mention present state q of n, or I'll
Excuse me,
mention
sir.
this.
Sir, someone will.
Yeah. So q of n or q of t, and so I'll take it as a t anukundam. So if I take it as a t, so q of n or t, anything is fine. So t ante general time and bettam kabatti it's fine. So q of t, okay, and the other one is q of t plus 1. Okay, so these are the two possible I mean, what are 4 possible conditions here? So first state is 0 to 0. Okay, so next is 0 to 1, and next is 1 to 0, and next it is 1 to 1. Okay, so these are 4 possible transitions available here. When, I mean, the present state is 0, and next state is 0. Okay, the present state is 0 and next state is 1. The present state is 1 and next state is 0. The present state is 1 and next state is 1. Okay, so these are 4 possible states that are available here, and we have to identify the inputs, so which are responsible for this 4 possible transitions here. Okay, so what we have to identify here is, so I have to identify a state, so where its present state is 0 and next state is 0. I mean, there is no change in the state. So this is no change in the state and oka conclusion draw cheyochu. Lekapothe I'll check the value of q of t plus 1 or q of n plus 1, so which is giving 0 value. Okay, so one case is, we have to see in 2 different ways here. So the first way is what we have to see here is, so 0 to 0, the present state is 0, next state is 0, so there is no change in the state. So this is one thing I have to check in the truth table. So మీరు ఎలా రాస్తారు అంటే ట్రూత్ టేబుల్ బేస్ చేసుకొని రాస్తారు ఎస్ఆర్ వాల్యూస్ ఇక్కడ. Okay, the first conclusion I can draw from here is 0 to 0, the state is changing from 0 to 0. So the meaning of this is, it is no change state. Okay, it is no change state. So that is the first conclusion. Okay, so second conclusion is, I have to check the q of n plus 1 or t plus 1 value. So this is the next state here. Okay, so next state should be equal to 0. Okay, so the first conclusion, so it is a no change state, and the second conclusion, okay, so next state, so I have to check the value of next state, that is q of t plus 1 value should be equal to 0. So next state column lo nen 0 ki check cheyali. Yes or no? Clear or not?
Yes, sir.
Yes, sir.
The first thing I'll be doing here is, I'll draw the conclusion here. The first conclusion is 0 to 0 means that is there is no change state here. That is the no change state. And the next conclusion is, so next state is 0. So next state is 0 and the q of n plus 1 is 0. Okay, so that I'll be checking that 2 conditions in the truth table. So no change states ekkadekada unnai manaku. So where are no change states? I mean, no change state is only this value. S and R value 0 0 అయినప్పుడు we'll get a no change state. Yes or no? Q and q of n undante there is no change state, right?
Yes, sir.
Yes, sir.
Okay, so that is a no change state. Okay, and S and R are equal to 0 0. So that is the first case. So S are 0 0 ఉన్నప్పుడు I'll get a no change state. So 0 to 0 is nothing but a no change state. Okay, other cases, next state is 0. Next state is 0 ekkada ochindi manaku? So next state is 0 ekkada ochindi? ఏ కేస్ లో వచ్చింది మనకు?
1 to 0.
So next state is 0. Next state q of t plus 1 0 ekkada ochindi? q of n plus 1 0 ekkada ochindi truth table lo?
0 1, sir.
Yeah, 0 1. S and R values are equal to 0 1 వచ్చినప్పుడు I am getting the value of q of n plus 1 as 0 here. The meaning of this is the inputs are 0 and 1. Okay, so now check this S and R values. So S value is a 0 and R value is a don't care. So R value is 0 and 1 and so for this case the outputs are equal to, I mean S and R equal to 0 and don't care for 0 to 0 state here. Clear?
Yes, sir.
Okay, so 0 don't care enduku vachindi ante, so there is a no change state. I mean, identify this as present state and next state here. So present state is 0 undali, next state kuda 0 undali, ante enti no change state. So no change state eppudu possible? So when S and R values are equal to 0 0, there is a no change state possibility here. Okay, and other thing is, like I can draw the conclusion here, like next state is q of t plus 1 or q of n plus 1 is 0. So q of n plus 1 value 0 ekkada undi? So for these inputs, so these 2 inputs are responsible for state change from 0 to 0. Okay, for it to remain in the same state, the values of S and R should be like this. So S value is 0 0, it's 0 only, and R value is either 0 or 1. So it is a don't care. Clear?
Yes, sir.
Okay, and next you check the next value 0 to 1. So present state is 0 and next state is 1. So the meaning of this is it's complementing. Okay, so complementing, there is no facility of complementation in case of SR flip flop. So even though we'll draw the conclusion here. Okay, so second case is, so we'll be having complementing states here, complementing states. So that is 0 to 1, so the state is complementing. Another case is like what I had to check here is q of t plus 1 is equal to 1. Q of t plus 1 is equal to 1. So q of t plus 1 ekkada 1 undi manaku. So what are the inputs responsible for q of t plus 1 is equal to 1? Q of t plus 1 ekkada 1 undi, q of n plus 1 ekkada 1 undi.
1 0.
A input combination
0.
1 0. So for 1 0, q of n plus 1 is equal to 1 here. Okay, so this is the thing, because there is no complementing state here. So q of n ante normal no change state. So but it is an indeterminate state, so we don't have complementing state here. So only the values of s and r will be equal to, so 1 0. So for the second combination, clear?
Yeah, sir.
Okay, and the third case, so 1 to 0. So present state is 1 and the next state is 0. So the meaning of this is it is a complementing state here, the states are complementing here, and we have to check for next state is 0 here. We'll check for next state is 0. So next state is 0 ekkada undi manaku. So next state is 0 for the combination 0 1. For the combination 0 1, we are having the next state as 0 here, but we don't have any complementing states here. Okay, and so the value of s and r will be equal to 0 1. Any doubts in this? Any doubts in this?
No, sir.
Okay, so present state is 1, next state is 0. So it may be complementing 1, or the second conclusion is the next state is 0. So next state is 0, it is here for the input combination 0 and 1, and we don't have any complementing states here, we don't have any complementing outputs here. So hence there is no conclusion, I mean we'll not have any inputs which are responsible for complementing the states here. Okay, so hence we'll go with this next state is 0, that is equal to 0 1. Okay, and next 1 to 1. So 1 to 1 we can draw the conclusions like no change state. Okay, that is the first conclusion, and second conclusion is next state is, so what is next state here?
1, sir.
Next state is 1 here. Okay, so where is no change state here? So no change state is s and r values are equal to 0 0. Okay, and so next state is 1. So when the next state is 1, so next state is 1 for the combination of 1 0. So for this combination next state is equal to 1 here. So what is the values of s and r here? So what are the values of s? So it is don't care 0. So the value is don't care 0. So this is the excitation table of s of it. Okay, so this is the excitation table of the s of it. Clear?
Yes, sir.
Okay.
Yes, sir.
You can check here. So S of flip flop. So take down this excitation table. So this is the excitation table here. So take down this one. So in excitation tables, we'll identify the inputs which are responsible for change of the state. Okay, we'll identify the inputs which are responsible for change of the state. Okay, whether it is present state is 0, next state is, there are 4 possible states here. So 0 to 0, 0 to 1, 1 to 0, and 1 to 1. So we have to identify the inputs which are responsible for this change of the states here. So that is about SR here. So excitation table of S of flip flop. Clear?
Yes, sir.
Yes, sir.
Next we'll go for D flip flop. D flip flop. Sorry. Why it's not coming? Okay, so there's a D flip-flop truth table. Okay, so I need excitation table right now. So excitation table, so same cases. So what we have to do here is we need this Q of n plus 1, Q of P or Q of n plus 1. So if I take it as P also no problem. So Q1 Q of n plus 1. Q of n. Okay, so the four states are the same here. So 0 to 0, 0 to 1, so 1 to 0, and 1 to 1. Okay, so what I have to identify here is I have to identify the input, only one input, that is D. Okay, so D flip flop is quite simple. So what is the equation for D flip flop? So what is the equation for D flip flop?
D, sir.
Into n plus 1.
Q of n plus 1 is equal to D. Okay, so what is the D value now? What is the D value? Q of n plus 1 is D, right? So what is D value?
0, sir.
Huh? Yeah, this is 0, fine. I mean, just general gift is saying. So D, Q of n plus 1 is equal to D. So D is also equal to Q of n plus 1.
Yes, sir.
Yes, sir.
సో డైరెక్ట్ గా మీరు క్యూ ఆఫ్ n plus 1 ఏదైతే ఉందో అది రాసేయడమే. ఓకే,
1, sir.
0. ఓకే, ఆర్ ఎల్స్ యూ కెన్ చెక్ లైక్ దిస్ ఆల్సో. లైక్ ఎలా చెక్ చేసుకోవచ్చు, సింపుల్ గా అయితే అది రాయొచ్చు. సో 0 to 0 స్టేట్. సో నెక్స్ట్ స్టేట్ ఇస్ 0. నెక్స్ట్ స్టేట్ ఇస్ 0 ఎక్కడ ఉంది? D0 ఉన్నప్పుడు. ఓకే, సో నెక్స్ట్ స్టేట్ ఇస్ 1 ఎప్పుడు ఉంది? D1 అయినప్పుడు. Okay, so next state is 0. Next state is 0 ఎప్పుడు ఉంది? D0 అయినప్పుడు. Next state is 1, so D1 అయినప్పుడు. Okay, so there are no complementings or no change states here. Okay, so this is the excitation table of the D flip flop. Yes or no?
Yes, sir.
Yeah, sir.
So D is simple here. So next we'll go for T. Okay, so T flip flop. So what we'll check here is T flip flop here. So please note that right. So next is T flip flop. So JK will see. Meanwhile, we'll see D flip flop also. So you have to tell. So meere cheppali idi. But don't get confused here. Okay. So Q1 Q of T plus 1 is all common. So Q of P, so Q of N. Q of N plus 1. N plus 1. So these things are same here. So 0 to 0, 0 to 1, 1 to 0, 1 to 1. So these things are same. Okay, and what we need here is like, so we need the value of T. We need the value of T. So check this case here. So we'll be having, what is the truth table here? So we'll be having no change state and complementing state here. We'll be having two possibilities here. One is no change state, other one is the complementing state. So what is the first state here? So 0 to 0 అనేది ఏం state అక్కడ? So what is 0 to 0?
No
Fast.
state.
So it is no change state, right?
Yes, sir.
Yes.
So no change state ఎప్పుడు వస్తుంది t0 ఉన్నప్పుడు. Yes or no?
Yes, sir.
Yes, sir.
Yeah, sir.
Yeah. So 0 to 1 it's a complementing state. So complementing states ante so t1 ఉన్నప్పుడు. Okay. So 1 to 0
1, sir.
complementing state. So hence t is equal to 1 to complementing question. So 1 to 1
0, sir.
no change state. So hence it is equal to t is equal to 0. Okay. So this is the excitation table of the t flip flop. Clear?
Yeah,
Yes,
sir.
sir.
Okay. Next, what we'll see here is so we'll see the JK flip flop. Okay. So there is a truth table of JK flip flop. Okay, you can see from here only. So there is the truth table of JK flip flop 0 0 I think Q of n. So it's just like SR flip flop, but 1 to 1 will be having so QN bar here. Okay, so Q of n bar. Okay, so you can check here. So what is the first case here? So 0 to 0. So we'll be drawing two conclusions here. So what is the first conclusion? No change state. Okay, and next state is 0 here. So when there is no change state, so when the values of j and kr is equal to 0 0 and next state is 0 and the value of jk is 0 1. Yes or no?
Yes, sir.
Yeah, sir.
So 0 0 is a no change state. So next state is 0 epudu vastundi manaku. So j is equal to 0, sorry, j is equal to 0, k is equal to 1. Okay, so j is equal to 0, k is equal to 1. Clear?
Yes, sir.
So 0 and 1. So it is nothing but 0, don't care. The value of j is 0 and the value of k is don't care. Okay?
Yes, sir.
Okay. And next value is 0 to 1. So 0 to 1 is a complementing state. Okay. So it is a toggle case. Okay. Another case, next state is 1. So the conclusion is it's a toggle state ఒకటి toggle case ఒకటి and next state is 1. So toggle case ఎక్కడ ఉంది? So jk 1 ఉన్నప్పుడు toggle case వస్తుంది and next state is 1 here. So next state is 1 ఎప్పుడు వస్తుంది? So next state is 1. So when j is equal to 1 and k is equal to 0. So these two cases here. Yes or no?
Yes, sir.
Okay. So now the value of j is 1. Okay. And the value of k is
Don't.
don't. Clear?
Yes, sir.
Okay. And the next case is 1 to 0. Okay. So 1 to 0. So 1 to 0 ఎప్పుడు వస్తుంది మనకు? So 1 to 0. So it is a complementing case, that is a toggle case. This one. So j is equal to 1, k is equal to 1 అని వచ్చినప్పుడు we'll get a toggle case here, that is a complementing one. Okay. And other cases like next state is 0 here. Next state is 0, we'll get it from j is equal to 0 and k is equal to 1. The toggle case is 1 1. So next state is 0 ఉన్నప్పుడు ఎప్పుడు వస్తుంది? So j is equal to 0 and k is equal to 1. Okay. So what is the values now? The value is j is don't care and k is equal to 1. Okay, j is don't care and k is equal to 1. Clear?
Yes, sir.
Okay.
Yes, sir.
So next, no change state. So 1 to 1 is a no change state. So no change state ఎప్పుడు వస్తుంది? 0 0 is a no change state and next state is 1 when j is equal to 1 and k is equal to 0. Okay, so that is like 0 0 1 state. So j is equal to 1 and k is equal to 0 వచ్చినప్పుడు వస్తుంది. So what is this case here? It is a don't care,
0.
don't care 0. Okay, so this is the excitation table of the JK flip flop. Okay, clear? One minute. So please mute. So take a note of that. Yeah, so take a note of this excitation table. Clear?
Yeah, sir.
Yeah. So this is about excitation tables here. Excitation table of JK flip-flop. So you have to remember this. So ఒకవేళ గుర్తు లేదు అనుకో ఏం చేయాలంటే మీరు excitation 2 tables రాసుకొని excitation tables draw చేయాలి. Okay. This is for JK flip-flop. This is for D flip-flop. This is for SR flip-flop. Okay. And this is for the T flip-flop. Okay. So we'll stop it for now. So I'll let you know. So once you are done with the class, let me know. So once you are done with that class, I'll be taking the class after 15 minutes.
Okay, sir.
Okay. Next class, we'll see the flip-flop conversions. So how to convert from one flip-flop to the another flip-flop. Right?
Okay, sir.
Yeah, sir.
Yeah. Thank you. You can drop your attendance and we can do.